Hello everyone, September 20th, Monday. Let's try to do it fast. Find winner on a tic-tac-toe. Oh, interesting question. Okay, so 2 players, 3x3 grid. Here are the rules. Player takes turns placing characters into empty square. First player A always plays X, okay? Second player always plays O. X and O are always placed into empty squares, never on filled ones. Game ends when there are 3 of the same character filling any row, column, and diagonal. Game also ends if all squares are then empty. No more moves can be played if the game is over. Given array moves, for each element is another array of size 2 corresponding to the row and column of the describing order in which A and B play. Return the winner of the game if it exists. In case the game ends in a draw, return draw. If there are still movements to play, return pending. You can assume that moves are not valid. The grid is initially empty and A will play first. So basically just it tells you, right? It tells you which move each one will play, and then you just output who wins, or nobody wins, or pending. This is an easy question. No repeated move, and I think all we need to do is find a way to check. I mean, it's a 3x3, so we can check after every move. Right, check out after every move. Like the state, right? Each one we have a state. After putting a thing, we can check, and the state will be one wins, another wins, pending, or draw, right? So how do we check the state? I mean, we can just iterate through, right? So rows. Is there any easier way to check? That is interesting. What will be an easier way to check? I mean, we will have their positions, right? We'll have their positions. So, say, like, we don't consider the grid. That's not necessary. We just, A is going to be playing X, right? And B is going to be playing O. That doesn't really matter. So it's just for A, right? All the position that A has. So we can record on the row. Okay, if we record on a row, that's fine. How do we record on the column? I mean, what we can do is, there are only 2 diagonals, right? So on A, we can just say, we can do it like an array, right? So we have 3 for all the rows, and we have 3 for all the columns, and we have another 2 for the diagonals, right? So it's going to be 0, 1, 2, and the array will represent the numbers we have on the row, and 3, 4, 5 will represent the numbers on column, and 6, 7 is going to be diagonals. So we can say 6 is diagonal on the, so on one diagonal it's going to be 0, 0, 1, 1, and 2, 2, and the other diagonal 0, 2, 1, 1, and 2, 0, right? So these are the diagonals. So basically when something comes in, we check, right? We check. Let's say 0, 0 comes in, right? We know 0, 0 belongs to row 0, column 0, and diagonal. Oof. How do we handle this diagonal thing? I mean, we can just say like minus, but 1, 1. How do you handle minus? Plus. right? Plus. No, plus is not going to work. So minus is 0, right? That's fine. Or plus is equal to 2. Right, I think that's the only one that has this. 1, 1, 1, 2, and then this is 2, 1, and 2, 2, right? So the upper left, lower right diagonal, what we have is the indices. The difference between the indices will give you 0. And the other way, the left, lower left, and upper right, will give you is the sum is going to be 2. Right? So these are the identifier. Okay. And then we also have the rows and columns. And it will be nice if the rows and columns can also be represented directly. Like the rows we can represent directly, right? The rows, but the columns we say the columns has to be plus 3. Right, so for the columns, we're gonna plus 3, and for the diagonal, zero diagonal gonna be plus 6. Damn, that's just very arbitrary. Is there a way to make this look nicer? Zero and 2. Okay. How about we make it? Yeah, let's make it into. This just feels very forced. Let's make it into a 3 by 3, right? So the first row is going to be for the rows, right? Rows will have 0, 1, 2. The second one will be columns, 0, 1, 2 as well, but we just do the columns. And the third one is going to be for the diagonals, right? For the diagonals, we should have 0 and 2. So we don't have 1, which is fine. And at the end, we just check, right? We're going to check. How do we check? Well, we check on each row, see if any one of this is 3. We check on each column, see if any one is 3. And we check on the diagonal, see if everyone. So basically, we check on every single one to see if there is any 3. Can we do this smarter? I don't think. Now it would be easier if we have only one row, right? It's easier to code if we have only one row, and we have. Let's just do a one row. Yeah, I like to do a one row, and column just went a plus 3, and the diagonal we just force it, right? Force it plus 5 or plus 6. Plus 6. Now we're talking. We just added one more. We just flatten the entire 3 by 3 into one row, and column gonna be plus 3, diagonal will be plus 6. That's it. And then at the end, we're just gonna loop through this array to find if there's any 3s, right? If there's any 3s, then one of them wins. Or both wins, right? Is it possible like we can have both wins? It is possible. If both wins, I guess it's a draw. Or they have 9 steps, but nobody wins. That's going to be a draw. So 9 steps, nobody wins, or both wins. That's a draw. If we haven't fit all 9 cells and there's nobody wins, then that is a pending. Okay, so that's going to be our data structure. All right, so let's pull it up. Here it is. Okay. So we're gonna same thing. Let's see. tic-tac-toe. I don't know, maybe I've done this before. Alright. So basically when I say A, B, right, equals to 0 times 9 and 0 times 9, right? And then when I say for I see what you're doing here. So I think we can just say players, right? This is players. And then we can say for I index ij, they enumerate moves, right? So when I say what are we gonna say? Plus 6 plus 3. So the rows first. So when I say players, index pi, player index, index mod 2, right? So I say players pi, so I'm going to go row. Row is going to be I, right, plus equal 1. Players pi, column is going to be j, but it's going to be plus 3, plus equal 1, right? And then diagonal. Diagonal will be, it has to equal to 2, right? So I'm going to say if I equal to j, right, then players pi, I can directly say 6, right? Well, directly say 6 plus equal 1, and if I plus j equals 2, then players pi. In that case, yeah, we only need 8. We don't need 9. Right, let me just do pi 7 plus equal 1. Right, so we do all that, and then what I'm going to say is I'm going to check, right? So A wins, right? A wins equals any player. So the C, for C in players 0, actually C equals to 3. And B wins, right? B wins the player 1. Okay, so I have A win and B wins. Now I'm gonna check if A wins, right? Return A. If B wins, return B. Oh, hold on. If A wins and not B wins, if B wins and not A wins, right? Return B. If A wins and B wins, right? Or len tic-tac-toe, not tic-tac-toe, len moves equals 9, return draw, right? And the last one would return pending. Okay? Let's see if the logic holds. So, when we have the first one, moves is this. So we have these moves, and the result is B. Second one, we have more moves. Oh, actually, that's the third one. We missed the first one. This is a draw. And then this is the last one. This is a pending. Yeah, you cannot check for pending just for like if like the number of moves is not sufficient. That's, you have to count, right? You have to count. This is going to be A. Okay, so here is moves. This tic-tac-toe moves. All right, let's try it. We pass. That shall be right. Okay, submit. Pending. Judging. Accepted. Nice. Yeah. This is an easy question. We only need to figure out a data structure, a scheme to record the number of X's and O's for each player. I should say X's and O's for each player. So the number of characters each player accumulates for all rows, columns, and then diagonals, diags, right? My choice is an array of size 8. I used first 3 positions to record the accumulation on row 0, 1, 2, the next 3 for columns 0, 1, 2, and the last 2 for down right and down left. Doesn't make any sense. Diags. The only trick I see is that the down right diag is defined by coordinates where I equals j, and the down left diag is defined by I plus j equals 2. And other than that, there's nothing. This one will run 01. Yeah, I mean this is 01 because it doesn't grow. I think this is not necessary. I just say let's call the time complexity as 01. Okay. Oh wow, we're very slow. We're very slow. They're around 65 milliseconds. It's only 5%. Right, there are better ways, huh? Let's see. Oh my god. I check winner. They're actually appending the board. Oh my god, there are appending the board. And when you check rows, check columns, check diagonals, and then check for pending. Nope. I don't know why that one is faster. I had no idea. It's like what, twice as fast. But it's 32, 65 milliseconds. That basically doesn't make too much difference. I don't know. Maybe they changed the number of test cases. Who knows? All right. This one, let's see. $1,275. Could be one of the contests, right? 1,275. Brute force. record each move. Let's just see the brute force. Get a board, check roll, they put player ID in it. The current player has 1, right? For each row, for each column, check diagonals, and then we check. Okay? They call it n by n. Record each move. -3. Row 0 equal 1. This is interesting. So we just okay, we keep if we just +1 or -1, +1 or -1. How about a column? Well, we can pick anyone to. Column. So that's for the rows. We can do. Are you saying that each one we have to consider all of them? Calculate the value for row and column, and check if the absolute value equals n. On the diagonal, or the anti-diagonal, then we'll check if the value equals n as well. So what we're saying is we're gonna get what? This value, this like all of this will be recording this. So this recording both the rows and columns. P1 move to 0, row 2 equal to 0. This one will be 0, and column 0. Or we get a new thing. Anti-diagonal equals 1. Rows and columns, to represent. 2 numbers to represent. This is similar to this. But I am adding. Like each one, I just keep adding. What they're doing is, we not only add, but we also minus, right? We also minus. And whenever something reaches 3, and we can return immediately. Row containing if the absolute value equals n. If all cells in the current column, what can now you do it at the end. Blah blah for row, and then there's a check every single thing. Complexity OM. Length of the board. Ours is OM. OM plus ON, actually. I like this one. I like this solution. I mean, I am close, right? I'm close. We're on the right track. But the trick of taking one player as -1 and the other player as 1, and then check the absolute value. That is smart. That is smart. In my case, I just keep adding them, right? I just keep adding them and then check both. And I think this one also costs a lot of time. So we're gonna change that. So yeah, let's do another solution. It's a good one. People are saying this is not easy. Well, it is easy. It didn't ask you to design anything. It didn't ask you to solve anything. Like what more do you want? This is as easy as it can get, right? So this is from the official solution. It's very smart. Kind of similar idea as solution one, but we only use one. In that case, we only use one array to record for both A and B, except when A makes a move, we add 1. But when B moves, we deduct 1. So at the end, we check whether, it's actually not at the end, at each move, we check whether the array contains any 3s, any value whose absolute value is 3, right? And that would determine the winner. Now, if no winner, hold. I just realized one thing. My solution will be different if let's see description again. How do you determine, right? So the game ends when there are 3 of the same. So actually this is not right. If someone wins, and that should be it. Which means I'm thinking about this, right? So we do 0, 0, and let's say the other one do 0, 0, 1, 0, 2, and then we do 1, 0, and the other one do 1, 2, right? And then we do 2, 0, and the other one do 2, 2, right? So the A is filling this row, this column, B is filling this column. Who wins? In my condition, it will be a draw. Oh, it's invalid. Wait, why is this invalid? Oh, because one of them is already done. So we stop moving if one of... so in this case, it's just if A wins and if B wins, right? And if this, which means we can put this one here, right? And then we can put this one here. So we don't need to check these two. So we can do this, and do this, and do this, and do this. Yeah. Let's see. Yep. Oh, look at that. So that is the trick. Because we check one of them wins, and then we don't have to check the other one. I think that's the reason. Anyway, doesn't really matter. I'd like to do the other solution now. So we don't have to wait for all of them to the end. Check, right? So this one, if no one check the array contains any value whose absolute value is 3. If no winner appears, right? If no winner is available, check the moves, right? Check the moves to determine whether we are pending or drawing or draw, whether it's pending or draw. Okay, so again, we're gonna have decision, right? It's called decision. What we call here players. Play, right? Play is gonna be 0 times 8, right? That's what we do, and then we do this, right? We do this and say if plays, right? And then play will equal to this. Actually, no. Plays is this. Play can be 1. And then we just need to do for ij, not enumerate, just in moves, right? ij moves. So I have play. Now what we're gonna do is plays I, right? Plus equal to play, and plays j plus 3 plus equal to play, right? And then if this, then plays 6, right? If this, then plays 7, right? But not thought plus equal to play. And once it's done, we're gonna check. How do we check? We just go through all of them, right? We go through all of them to see if there is a 3. So I want to say, oh, how do we determine? Like if it's a 3, we say true. If it's a -3, we say true again. And how do we know? We know based on the play, right? Because it's after this play, this player plays it. So we can say if any, right? C ABS C equals 3 for C in place. I like to use P. So if this is this, then return A. If play equals 1, else B, right? If not, play times equal -1. So we'll go to B's turn, right? So once we're all done, then we're going to return draw. Right? If land moves equals 9, else pending. Okay. So solution 2. Ugh. That is not right. Something is not right. Alright, so ij with plus plus, right? And then 6, 7, that should be right. And we say ABS this, equals P. Jeez, equals 3. There we go. Alright, let's check this. Submit. Yep. Yeah, this is a smart, very smart way. It's shorter than the one I had. All right, that's it. It's a good question. It's a very good question. Even if it's an easy one, it's a good question. All right, I'll see you guys tomorrow. Adios.